Welcome to Sairam Triple YouTube channel. Let us discuss Model 2 Stability Analysis Tools for Smart Grid. See here, the system must be stable while operating power supply or power generating or power transmission or distribution, right? In this topic, we are going to discuss stability analysis tools. I mean, what are the tools we are using to make that smart grid stable operation. So, introduction to stability and strength and weaknesses of existing voltage stability analysis tools. See here, we have so many weaknesses in the present power system analysis tools because so whatever we are generating and how much we are generating and how much we are utilizing, there is no idea between generation and distribution or consumption, right? So in the smart grid, there is a manual is present, but in the smart grid we have a digitalized or smart or automatic power recording or power supply system. So here we are using to maintain stable ability to stable the system. So we have some of the tools, and also uh, we are going to identify what are the weaknesses are present in the existing voltage stability analysis. In the smart grid and the power grid. So how it becomes a smart grid and all. So voltage stability assessment, here also we are going to discuss some assessments um, in the voltage stability analysis. Voltage stability assessment technique also will be there. So how to stable the system, how to maintain the voltage stable, I mean constant. So that also we're going to discuss by using voltage stability assessment techniques. Voltage stability indexing. So here also indices, some indices will be there, and able to stable the system. Analysis techniques for steady state voltage stability studies. See here, there is a constant steady state. I mean steady state in the sense what, constant. There is no like dynamic steady state voltage stability analysis. So constant, we have to maintain the power supply system. So that also we are going to discuss here. Application implementation of plan of voltage stability, optimizing stability constraints through the preventive control of voltage stability analysis. So here also we are going to discuss application and implementations. How to it is applied to the applied to practically, and how to implement power system supply system. Also we are going to discuss, and angle stability assessment. So here also some of the different criteria, different uh, like angles will be there to maintain a stable operation in the power system components, and estimation of state. So how to estimate, and then what are the estimation in the smart grid to implement in the existing power supply system, existing power generation, distribution, and utilization, transmission also. So let's move on to the next slide. So we have introduction part of stability, ability to stable the system. As electric power network worldwide expand to accommodate more generation. See, so smart grid system is basically for highest power production. I mean, like implementing power supply system into the highest power supply, electric power network, and worldwide. See, if you implement a smart grid into the present grid, so it accumulate more generation, because at present everything is like a manual operation, right? So if suppose if you implement smart grid into it, definitely it's automatic, and then it's a digitalized and sensor based. So and control the devices here. uh, Smart grid which controls the devices, automatically, and intelligent power supply and intelligent controlling the physical and technical consequences resulting from the weaknesses. See, there is so many weaknesses at present. So if suppose if you implement smart grid, definitely we can eliminate that weaknesses, right? And in generation, transmission, distribution, it will become more costly to the society. Like if suppose the present grid, there is so many losses. So that losses we are going to apply to the customer side. So if suppose once the smart grid is implemented, definitely the overall cost will be reduces. So consumption and generation, it will manage everything, right? So generation, transmission, distribution, where we need to place sensors, where we need to become displaced power supply system, displaced transmission distribution. Also, we are going to discuss and environmental impacts also. Strength and weaknesses in the power supply system, uh, voltage stability analysis tools. So there is so many tools will be there for smart grid weakness. Like identifying the strength and the weaknesses, existing voltage stability analysis tools that are incorporated with analytic tools for the existing power system networks. So there is so many techniques we are going to utilize here. Voltage stability and voltage collapse. Voltage stability has often been viewed as a steady state viability problem suitable for static analysis techniques. So static analysis techniques is a constant analysis techniques. It's a continuous also, but it must be maintained at a constant level. So the ability to transfer reactive power from the production. See, reactive power we cannot use, right? So reactive power can be reduced into active power, right? So here in the smart grid we can eliminate reactive power and wastages also, and other drops also, right? So it's a continuous power supply system with intelligent displaced source to the consumption sink during the steady state operation condition in major aspects voltage of voltage stability. So it reduces, sink, it capture less, sinking the power supply system, and then it passes power supply or voltage or current or whatever, so become to make a active, right? So that's also will be there in this system. And also we have classification of voltage stability. There is three categories voltage problems are first one is primary primary phenomena related to the structure reflect the autonomous response and of the system to reactive supply demand imbalance. So this is the first classification of voltage stability, reactive supply and imbalances. So